We're going to start with the middle of the chart where it says atomic number. That equals A equals P equals E. That means atomic number equals protons equals electrons. The mass number is protons plus neutrons. And then to get neutrons, it's mass number minus atomic number equals neutrons. So M minus A equals N. The next thing I'm going to label is the 1A and 2A. That number tells you the number of valence electrons. So all of these, I'm not going to label all of them, will tell you the number of valence electrons. And valence electrons are found in the last shell of an element, and it also tells you how reactive an atom is. The next thing we are going to go over is to group 6A or 16. Circle a whole group. These are called groups and families. And they're grouped together because they have similar properties. And they have the same number of valence electrons. The next thing we're going to label is our metalloids. If you take a marker, highlighter, or if you even take your pencil and shade in, all the elements except for aluminum that are on the dark bold staircase line are metalloids, and it separates the chart between the metals and the nonmetals. Sometimes number 85 is highlighted, so I'm going to go ahead and highlight that one. Sometimes it isn't. And let's label that metalloids. And metalloids have properties of metals and nonmetals. All the metals are on this side of the chart, on the left-hand side, and then nonmetals are on the left-hand side, or on the right-hand side. So let's label that as your nonmetals. And then that means the rest of the chart is metals, with the exception of hydrogen. Hydrogen is a nonmetal. The next thing we're going to go to is group 8A. We're going to label this one stable. It's the stable group of the periodic table, also known as the noble gases, because it has 8 valence electrons, and that is the magic number for elements to be stable. Number 17 or 7A is very reactive because it only needs one more valence electron to be stable. And then the next thing we're going to do is go to the side here. And I mentioned also how number 7A was very reactive. Number 1A is also very reactive. It's the most reactive group because it only has one valence electron. Those are the alkali metals, and they react very violently with water. And then the numbers on the side here are called periods. And this tells you the number of energy levels or shells. That means if it's in period 1, it's going to have 1 shell. If it's in period 2, it's going to have 2. In period 3, it's going to have 3, and so on, all the way to 7. The next thing on our chart is, at the top, we're going to write down some signs of a chemical reaction. Let's write chemical reactions. And the first thing you'll notice is unexpected color change. Like if something started out clear and it changed to bright purple or pink or blue. The next thing is unexpected temperature change. The next thing is precipitate. And this happens when you have two liquid chemicals and they mix and they form a solid or a cloudy substance. The next sign of a change is gas. That includes bubbles or fizzing. And then the next one is smoke, fire, and then finally we have light. For example, it would be a glow stick. Next thing we're gonna label is at the bottom. You have to know the charges of the subatomic particles. Subatomic particles are the proton, neutron, and electron. Protons are positive, neutrons are neutral, and electrons are negative. These two are found inside the nucleus of an atom. And then the electron is outside the nucleus on the energy levels or shells. On the side here, I'm going to write a formula for glucose. It's sugar. The underlined parts or letters are the elements. This has 3 elements: carbon, hydrogen, and oxygen. To get the number of atoms, you add them all together. So it would have 24 atoms. And then you might have some formulas that have a coefficient or a large number in front. And what you would do with that is it would multiply or carry to all of the subscripts of your formula. The next thing we're going to do after we finish labeling the front is flip it to the back. On the back, you have your 3 formulas. The first one is density, which you learned about in 6th grade. And sometimes you'll have to calculate. And we use this triangle to find parts of the formula that are not given to you. And you would set it up like this. The way it works is if you're trying to find mass, you would multiply density times volume. To get volume, you would you would divide mass divided by density, and to get density, it's mass divided by volume. The next one is calculating speed. And you do the same steps, dividing and multiplying. And the third formula is part of Newton's second law, or force equals mass times acceleration. And you would follow the same steps. So if you're trying to find the force, you do mass times acceleration. If you're finding the acceleration, it's force divided by mass. If you need to find the mass, it's force divided by acceleration.